Assalamualaikum and hi, we are from SSCE 2193, section 41 will be presenting about Lajakkuruih Tablet B. We are Muhammad Daniel, Alif Muhaimin, Suhail Azmin and Afiq Irfan will be presenting our part respectively. For introduction, Lajakkuruih is a company that produces diet tablet ranging from A to O. There are 200 samples of data from December 2021. We will analyze about diet tablet B based on the data randomly distributed. This is the numerical method for each categories including average, mode, standard deviation, and sample variance. This is the analysis based on shift for sum. Based on the table and the bar chart, we can clearly see that morning shift have the highest production rate. This is the analysis based on shift for average. Based on the tabular and graphical method, we can see that morning shift have the highest production rate. This is the analysis based on shift for variance. Based on the table and the bar chart, we can see that morning shift have the lowest variance, means it has the most consistent production. This is tabular method, which is analysis based on categories. We can see that highest frequency of weight is at row level 350 to 360, which is 56. This is tabular method, which is analysis based on categories. We can see that highest frequency of relative density is at row level 86 to 88, which is 85. Lastly, this is tabular method, which is analysis based on categories. For tensile strength, we only use small range, which is 0.1, because the data is not that much. We can see that highest frequency for relative density is at row level 7, which is 39.
For the part B, we need to use goodness in fit test where we find the hypotenuse statement H naught is the weight of the standard tablet produced by manufacturer, follow the normally distributed and the standard deviation, while the H1 is the weight of the standard tablet produced by manufacturer, then does not follow the normally distributed and the standard deviation be given. Then we construct a table that called test statistic consists of range of weight, observed frequency, probability, and expected frequency. But we cannot start the test yet because some of the observed frequency is less than 5. So we need to merge them. If the frequency is no more or less than 5, we can start find the statistic. And the sum of the statistic will be the chi-square test, which is 2.2144. At alpha equal to 0.05, from the Tai Chi graph, we found that the rejected value will be 11.0705, while we get the statistic test equal to 2.144, which is we fail to reject the H naught. So we can conclude that the weight of the standard tablets produced by manufacturer does follow the normally distributed and the standard deviation given.
For part C, we are using the analysis of variance test, or also known as ANOVA. ANOVA test is used to measure whether the mean of 3 or more population are same or not. And for this problem, we are using ANOVA test to measure the significance difference between tablet weight from the different shift. This is the table of tablet weight from different shift. From the raw data, we sort everything according to their shift. So the first column we have morning shift, evening shift, and night shift. There are 200 of data and our total number of treatment is 3. By using Excel, we can get the ANOVA table. So the first table comprises of the groups, total count, total sum, average, and the variance. So we have 3 groups which are morning, evening, and night. So from the second table, we have source of variation, sum of square, degree of freedoms, mean of square, F test value, P value, and F critical. So for source of variation, we have between groups, which denote as SS treatment, and within groups, we denote as sum of square due to errors, and for total, we denote as SST. So to calculate the degree of freedom for between groups, we can calculate by using total number of treatment minus 1. For within groups, total number of data minus total number of treatments, and for total number of data minus 1. And to calculate the mean of square, we can use the sum of square divided by the degree of freedom. And to calculate F test is using the mean of square of between groups divided by mean of square within groups. So we have F test. P-value and F critical is F alpha and then K minus 1 and N minus K, which are F 0.05 to 197. We can get this from the distribution table. So we have two hypothesis tests. The first one is by using p-values. So our H null is mu1 equal to mu2 equal to mu3, and our H alternative is mu I is not equal to mu j for at least one ij. So we reject H null if p-value less than alpha, which is 0.05. In this problem, our p-value is 0.655331. So which means 0.655331 is greater than 0.05, and we fail to reject H null. And our conclusion is there is no significant difference between tablet weight from the different shift. Next, our hypothesis test is using F distribution, and our H null is mu1 equal to mu2 equal to mu3, and our H alternative is mu I is not equal to mu j for at least one ij. So the decision rule is we reject H null if F calculated or F test is greater than F critical. In this problem, our F critical is F 0.05 to 197. So our F calculated or F test is 0.423522, and our F critical is 3.041753. Thus, our F test is less than F critical, and we fail to reject our H null. To conclude, there is no significant difference between tablet weight from the different shift.
Okay, for part D, tablet hardness can be represented by its relative density and tensile strength. And then, the tensile strength depends on the relative density. Therefore, we can conclude that tensile strength is dependent variable, which is y, and relative density is independent variable, which is x. Since there is only one response variable and one predictor variable, this relationship can be modeled by using simple linear regression. Before that, we have to check 4 model assumptions to apply this model, which are: the error are normally distributed, the mean of random error is 0, the variance of random error is an unknown constant, and the error are uncorrelated. After these assumptions have been considered, the simple linear regression equation can be expressed as y bar equals to alpha plus beta x, where alpha is the intercept and beta is the slope. We can get the value of alpha and beta in Excel output. Based on the table above, the information of alpha and beta are represented by the first column, which is alpha equals to negative 0.17248 and beta equals to 0.082586. From beta, we can infer that a unit increase in relative density lead to a 0.082586 unit increase in tensile strength of tablet produced. Recently, a batch was found to produce cluster of tablet that show low relative density. Therefore, with simple linear regression, we can make the prediction of tensile strength for such tablet. For 68% relative density, we obtain tensile strength is 5.4433 megapascal. For 74.3% relative density, tensile strength is 5.9636 megapascal. And lastly, for 80.1% relative density, tensile strength is 6.4426 megapascal. Based on live feed plot, it shows that the plotted data are not too far away scattered from predicted line. This shows that the relationship between tensile strength and relative density have strong linear relationship. Apart from that, we can use correlation coefficient to measure the relationship between variables. From regression statistic table above, we obtain the value of sample correlation coefficient from multiple R, which is 0.840707. As the value is close to 1, it indicates that the linear relationship between tensile strength and relative density has strong positive linear relationship.